This video shows the live removal of a link to a disconnecting circuit breaker in a 132 kilovolt high voltage indoor substation. This is done to enable maintenance of a disconnecting circuit breaker without taking the line out of service. The operation is carried out by a specially trained crew in accordance with applicable laws and safety regulations. This is not an instructive video to show how this type of work is done. Working with high voltage can cause damage to property, injury to personnel, and can in the worst case lead to death if it is not carried out in the correct way. You will now see how you can perform maintenance on a disconnecting circuit breaker without taking the 132 kilovolt substation and the lines out of service. The substation has a ring bus setup containing 2 lines, 2 transformers, 2 bus bars, and 4 disconnecting circuit breakers. Each transformer is connected to 1 bus bar. In this particular case, 1 bus bar and transformer are taken out of service to enable maintenance of one of the disconnecting circuit breakers. Furthermore, if there also had been a disconnecting link between the bus bar and the disconnecting circuit breaker, a live removal from the bus bar could have been made. In this way, both the transformers and bus bars would be unaffected by maintenance. Since there are no conventional disconnectors in the substation, the physical separation needed to enable maintenance of the disconnecting circuit breaker while the line is kept in service is achieved by the removal of the links between the line entrance and the disconnecting circuit breaker. This animation will show in a simplified way how the disconnecting circuit breaker is taken out of service. The first disconnecting circuit breaker is operated and locked in its open position. Next, the second disconnecting circuit breaker, which is the unit that will receive maintenance, is operated and locked in its open position. The medium voltage breaker connected to the transformer is also opened and disconnected. The bus bar and transformer are now fully disconnected from the incoming line. The bus bar is thus out of service, and the motor-operated grounding switch grounds the bus bar. The links to the line entrance, which are still live, are removed. It is now safe to start working on the disconnecting circuit breaker while the line is kept in service. First of all, the clamp to the line entrance is loosened. At the same time, it is very important that the link is kept in a steady position so that it cannot fall and hit personnel or the other faces. An isolation rope is attached to ensure that the link is not unintentionally twisted during removal. The link is carefully brought down and finally, the link is grounded. The same procedure is repeated for the remaining phases. The links are attached to the stand to keep them from moving. Here we can see the line entrance, which is still live, but physically disconnected from the DCB. The disconnecting circuit breaker is now grounded on both sides of the terminals, both towards the bus bar and the line entrance. It is now safe to start working on the disconnecting circuit breaker. After completion of maintenance, it is time to put the disconnecting circuit breaker back in service. The ground is removed from the link. Three isolated rods are used to provide maximum safety and stability when the link is reconnected to the line entrance module. The bolts are tightened with a torque wrench, and after this, the isolating rods can be removed. The same procedure is repeated for the remaining phases. The de-energized parts of the substation can now be put back in service. The motor-operated grounding switch on the bus bar is opened first. Next, the disconnecting circuit breakers are unlocked. They can now be closed to put the bus bar and transformer back in service.